Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's webinar, Building Cross-Platform Play for Your Multiplayer Game. It's brought to you by Gamasutra, Amazon, and broadcast by UBM. I'm Chris Graft, Editor-in-Chief and Publisher of Gamasutra, and I'll be your moderator today. We just have a few announcements before we begin. So you can participate in the Q&A session by asking questions at any time during the webinar. Just type your question into the Q&A text area located to the right of the presentation window, and then click the Submit button. At this time, we recommend you disable your pop-up blockers, please. The slides will advance automatically throughout the event. You may also download a PDF copy of the slides by clicking on the Additional Resources button located below the presentation window. This webinar contains audience polling, so please complete the polls when they appear. And if you're experiencing any technical problems, please visit our webinar help guide by clicking on the help link below the presentation window. In addition, you can contact our technical support helpline, which is also located in the webinar help guide. So now on to the presentation, Building Cross-Platform Play for Your Multiplayer Game, and I'll let our presenters take it from here.
Hey, thanks, Chris. Hello, everybody. My name is Bruce Brown. I'm a software development manager on the Amazon GameLift team. I'm responsible for the Flex matchmaking service. I've got about 12 years here in the software and gaming industry, both at Microsoft and Riot Games, and now at Amazon. And currently, I'm playing Zelda Breath of the Wild with my son on the Switch. Peter, do you want to tell us a bit about yourself?
Sure. Hey, everyone. I'm Pete Chapman. I'm a solutions architect, and I work in the Amazon Game Tech team. So what I do is I help customers in the gaming industry build new solutions around gaming. I focus 100% on gaming customers and the core technologies we have around gaming as well. So really sort of getting into the details about what they want to do with games, how they want to extend their games into the cloud and make great use of them. So it's an awful lot of fun. Absolutely love it, and it's great for me because I'm a massive gamer. I'm actually currently playing my Switch as well. I'm playing Axiom Verge, which I'm finding very, very challenging in the hard mode.
Yeah, for sure. Love that game.
Yeah, awesome. So Bruce, would you like to introduce what we're going to be talking about today?
Yeah, for sure. So what are we going to be talking about? Well, we're going to be telling you today about why you would want to potentially add cross-platform play to your game. We'll be diving in a bit to matchmaking and cross-platform play and how these two things interact, matchmaking being kind of a key part of cross-platform play. Next, we'll tell you how you can actually simplify your overall backend services architecture with Amazon GameLift and the addition of cross-platform play. And then finally, we're going to be looking at what all the pieces look like when they're all put together to present a fully implemented cross-platform play solution using AWS as a reference example. So with that, we're going to dive right into cross-platform play. And we're finding that developers are adding cross-platform play to their games, and they are enabling people to play the same game session with one another across devices. Well, why is that? Well, let's dive into some of those reasons. Peter, take it away.
Yeah, thanks, Bruce. I think the first kind of big reason around why cross-platform playing games is becoming important is the players. It's really a focus on how we can get players to engage in games in a greater way. And the first reason for that is how can you tie together and widen the player base by allowing them to play more platforms than they would previously. A lot of the times, gamers will have one primary platform they'd have purchased and really sort of invested in that one platform. And maybe they find that their friends are on another platform, for example. So, you kind of have that thing where you've got your platform, you want to play against someone else, but you can't because, you can't play across those two different platforms. And that can be a real challenge. And even if actually somebody did have, say, for example, one or more of the available gaming platforms to play on, often, and I experience this, often I'll just pick one of those to buy my game on. And really you end up in that same situation where you're kind of locked down to one one of those platforms to choose from when it comes to actually playing a game, and then of course playing with your friends. So that's really one of the big blockers, and I think it's one of those things that we're starting to see tear down with games that are starting to break those boundaries. And as I say, it really opens up the opportunities for players to play their friends and engage with them, in a much deeper way.
Yeah, for sure. One of the things that I like, in addition to what you stated, was if I have purchased the game across multiple devices, I can actually play and have the same experience, on the way to work in the morning on the bus. Maybe at lunchtime I break out my laptop, I get in a couple of games at lunch. I come home, I switch to my console. I'm still playing the same game. I'm still playing with the same people. And I think that's one of the real powers here of cross-platform play.
Yeah, I agree, and I think it speaks to kind of how gamers are starting to evolve. We're all becoming a little bit more time poor, I think, and allowing us to engage with games in more ways and have that continuity is really improving things for people. So that's really important.
Yeah.
So Bruce,
sure.
how do we move on to that next step, I guess, is the question. And what's the second piece that's involved? And I'd say that's really building and managing a unified player community. So when it comes to that, how do we actually manage one player base with a bigger and stronger, more loyal community? Essentially, we allow developers to engage with a wider group of players in one single way. Previously, when we were had those siloed platforms, essentially we would have the challenge as developers to actually engage with each individual one. They might have slightly different situations and scenarios based on the platforms they're playing on, and it made it harder for developers to really engage with the players in one single way. So when you actually open up and break those platform boundaries, you can have developers engaging with that one wider group. So do you have any sort of thoughts on that, Bruce?
Yeah, I really love this aspect of cross-platform play. As a game developer, now I can just interact with my entire player base in a consistent way all at the same time. It makes managing my community easier. It keeps players part of kind of one big community, right? And then in addition to those things, it increases the connectedness with the game, essentially, by increasing the pool of people that they can play with, that they can meet, they can form that community together with.
Yeah, it really does open things up, absolutely. Yeah. So, Bruce, would you like to talk us through item number 3 as to why we think cross-platform playing games is important?
Yeah, so this is a subject that's pretty near and dear to my heart, matchmaking. And what you can find with cross-platform play is you get a double benefit here. By having that single larger pool of players to choose from, you can actually decrease wait times. You have more players that are available to match. And you can actually increase the match competitiveness. With more players available in total, you're going to get a larger distribution of players within the different skill bands and have a higher chance of creating that high competitive match. So I really like cross-platform play when it comes to matchmaking.
Yeah, I think one of the key things here is decreasing those wait times, going back to that time poor aspect where, let's say you're engaging when you want to play a game in a mobile scenario and setting. You really can't afford to have long wait times when it comes to matchmaking and getting into that game because, you could be on the bus or on a train, you've got a good connection, but you don't know how long for. And, you just want to play that quick session and jump in and have some fun. And I think that's one of the real important factors here is, making that seamless and quick for players to jump into those games. And then, of course, have a great game whilst they're there as well.
Yeah, absolutely. And then finally, what I would say here that we're looking at when we're looking at cross-platform play in games is simplifying your backend architecture. As you're going to see in the talk today, we have an opportunity to support many platforms and actually simplify that backend architecture. Pete, you want to tell us a little bit more about that?
Yeah, I'd love to. This is something that's very dear to my heart, as you'd probably expect from an essay. I really do like the way that we approach things in terms of how to build back-end infrastructure and architecture. And one of the guiding principles we tend to have around these things is build once. Build it for as many different scenarios as you can support. And when it comes to cross-platform play, we're really looking to build an architecture that supports all platforms. And then really have it kind of evolve and support all of those different scenarios that you're going to throw at it throughout the course of its life. So I think we're going to see this as we go through some of the further parts of the talk. But it's really, really core to our heart, and it's something we can really talk to when it comes to sort of making sure things are running smoothly in the long term, and also supporting your game for the longer term.
Yeah. Well, shall we get into it?
Let's go for it.
All right. So let's talk about matchmaking. Before we dive into the architecture, you need to kind of have that key component, right, of your game architecture that's getting players into games. And that's why matchmaking ends up being so important in this scenario. So what are some of the challenges, though, that you have when trying to come up with a good matchmaking solution? We already touched upon wait time. That's the time that it takes for players to find a match once they've submitted a request. We've talked about competitiveness. That's the relative skill levels of the players in the match. We can talk now about player latency. That's the amount of time that it takes players to send information to and kind of give information back from the game server itself. And then cost. This is the amount of money that is required to actually host those matches on game servers. Pete, what do you think of these challenges?
Well, when I look at all of the challenges that are on here, I see two things. I think the first three directly impact and benefit the player. You're reducing those wait times, as we touched on before, and making that competitiveness higher. So you're really improving that experience in the game, along with the player latency, of course. And I think that's great for players directly. And then if you look at the last one, the cost, well, that benefits the developer directly as well, obviously making it cheaper to run, and of course support the player base. So when you take all of them together, though, really what you're looking at here is a set of benefits that really benefits both the players and the developer collectively. That you're going to get more players playing because of the first three, and that's going to make the developer more successful. And then, of course, the final one is just going to help in terms of cost optimization and efficiency, and of course allowing them to support more players more easily. So that's really nice. It creates a nice cycle of kind of benefit for everyone, I think.
Yeah, definitely. So if we want to take a look at what a typical solution might look like here to kind of take on those challenges, decrease wait time, increase competitiveness. Let's say, for example, maybe you're on Amazon Web Services and you have data centers here throughout the world that players can connect to get game servers. And let's say now you decide that you're going to set up your matchmaking server in a single region. By having all of your player requests, these players are popping up all over the world, and sending those requests to a single matchmaker, that allows you to pool those players together. You could have matchmakers in each region. You could have matchmakers in each of these data centers. But what that's going to do is that's going to fragment your player base. So if we're trying to create that kind of single large group of players to pull from to, like I said, decrease wait time, increase competitiveness, you can set up a single matchmaker. And so you'll have player requests going to that matchmaker. Players will then be selected for a match. A server will be selected to kind of address the latency question here of finding the lowest latency server for all of these players to connect to. The players will then connect to that server. They'll get the IP and port information, and then they're away playing their games. The interesting thing that cross-platform play adds to this complexity, some of these challenges, is let's say that those three players in the Western Hemisphere are on PC, and that player in the Eastern half there is actually on mobile. If you're not enabling cross-platform play, you're further segmenting your population. You're actually going to prevent this match from being able to take place. And sometimes you might have low population PCs or maybe lower population mobile, depending on the type of game. And what you really want to do is you want to get as many people into that single matchmaking pool as possible. Pete, what do you think?
Yeah, I completely agree. And the thing I do like about this diagram here is that it shows just how cross-platform play can really benefit certain types of players. In this case, obviously it's not to scale or anything like that, but you look at this scenario, we've got many PC gamers playing a particular game. They're connecting into to matchmaking and of course play a session, and you've got that mobile person, sort of over there, sort of representatively, smaller group of players that trying to matchmake against each other. That mobile player is obviously going to benefit from that much wider pool, which I think shows in really sharp relief. It's quite a nice way of displaying that. And collectively, everyone gets a better experience because, again, that pool is greater, everyone can play together, and they can all enjoy the collective experience together, which I think is really great.
Yeah, for sure. So, Pete, Next up, we're going to dive into simplifying your matchmaking architecture. I know this is kind of the thing that you're most excited about here with this talk. Is there a way that we can actually achieve the desired flexibility in matchmaking while not increasing complexity? It turns out that there is, and Pete, why don't you tell us more about that? Well, actually, sorry, before we get into that, Pete, do you want to talk a little bit about GameLift itself first?
Yeah, absolutely, happy to. So one of the great things about GameLift is it gives you the pipeline of tools to be able to take your dedicated game server and deploy it to the cloud very, very easily. Essentially, it's possible to do that in minutes. We have a few different concepts just to introduce you to here to begin with. The first being builds. So essentially, a build is your dedicated game server that's been integrated with the GameLift server SDK. And you upload that to GameLift, and you can support multiple builds and have multiple builds in GameLift at the same time. So if you want to kind of test different versions, things like that. And then what you can do is you can essentially deploy that build to a GameLift fleet. And a GameLift fleet is a structure, and we'll see a little bit more of this in sort of more of a graphical representation in a minute. But a fleet is really a way to scale up and down your dedicated servers on Amazon virtual machine infrastructure, essentially. And that can scale up and down based on your demand for players. And then thirdly, you configure your game client. And your game client is really all it needs to do is it needs to actually ask GameLift to do certain things like, for example, in this case, matchmake. So please find a match for this player. I've got this set of skills. I'm this sort of level in the game, and maybe I've got some latency information I pass into that as well. And essentially, it will then interact with GameLift, and of course, we'll get a match and pass that back. And then thirdly, you connect your players right up to the dedicated game server, and you have a very, very low latency experience. And we'll see this in practice in just a second. But before we do that, I'll just pass over to Bruce just to quickly talk through some of the reasons behind GameLift.
Yeah, so why would you choose Amazon GameLift for this kind of core component of your cross-platform play solution? I think that there are a couple reasons that generally jump out to me. First is low latency. If you have your fleets that Pete was just telling us about in all 14 of the regions that GameLift is in, you can see a global latency of around 50 milliseconds for all of your players, which is a nice fast connection time to the game servers. In addition, you can see up to 90% cost savings over any solution that you might build in EC2 yourself. EC2 is one of the hosting services for servers within Amazon. And you can get that 90% cost savings with what we call Fleet IQ on GameLift. And Fleet IQ will determine whether or not these lower cost servers that we can make available to you are actually available, and kind of ensure that you keep that connectivity that you're expecting to have for your players. Next up, something that I also think is pretty cool, GameLift will automatically scale up and down with player demand. And so as you see a burst of players come in during those peak times in the evenings, GameLift could automatically scale up game servers for you, and then once that demand drops back off again, it'll scale those game servers back down. So you're just paying for what you need when you need it. And then finally, it's actually proven by live games. We have a number of games now that are taking advantage of GameLift. If you had a chance to tune into our talk at GDC, you heard from Ubisoft's For Honor and Ilphonic's Friday the 13th. Two games that have achieved some pretty good success using dedicated servers offered by GameLift. So Pete, with those benefits of Amazon GameLift and kind of talking about it at a high level, do you want to dive into what that architecture of GameLift looks like?
Yeah, we'd love to. So we looked at some of those core concepts just a second ago around GameLift. And this is going to be more of an end-to-end view and flow of how GameLift actually works with clients and how you can kind of integrate it. So we start with the clients here on the left-hand side, and they're, obviously in this case, represent a couple of different types of devices. We've got sort of computer-based devices and mobile devices here. And the first thing that we're going to need to be able to do is have the clients call into something to make the request for, a session to be matched for. So essentially, my player is ready to play a game. They want to play a match, and they're looking to find a group of people to play against. And this is represented in this diagram by what we call a game service. Now, a game service can actually be anything that's able to integrate with our AWS SDK. Could be something you already have, running on your own infrastructure. Could be something you already have in the cloud somewhere. It's really kind of up to you. And it actually could be something you build specifically for this. And I'll show you some an example of that towards the end of the talk today. So once we've got that call in and we've accepted it, we'll need to actually make a call into GameLift FlexMatch to start a matchmaking process. And so the game service is going to make that call in, and it's going to ask for that to happen. And FlexMatch will essentially run the GameLift FlexMatch rule set that we have, and we'll touch on some of these as well a little bit later on in the talk. And what it will do is it will run it against the algorithm and find a match for the player request that's suitable. That can be based on various different rules, including teams and things like that. And it will pass that request on once it's found a match to what we call a queue in GameLift. Now, the queue's job is to basically figure out where in your GameLift infrastructure is the best place to put a game session. So this is where we come back to fleets. Fleets, as we said, are kind of essentially an auto-scaling group and set of configurations for your game servers. In this case, we've got several fleets. We've got one in Virginia, one in Frankfurt, and one in Singapore. And the queue's going to try and find out, well, okay, which one's the best location around the world to put this game session? There's two ways you can do that. There's actually priority. So you can say, well, actually, I'd prefer people to play in Virginia or Frankfurt or Singapore, and then have a sort of a completely ordered priority list of all of your fleets. Or you can do it based on latency, and you can have your clients essentially ping latency information, ping the AWS regions, and then send that information in when they make their request, and the queue itself can find that best fleet based on the latency information. Let's play that through quickly in terms of an end-to-end process. So as I say, we send the request in from the clients, and the game service interprets that, and it turns it into a request into FlexMatch. FlexMatch then accepts that request, and then runs the matchmaking algorithm against its rule sets that you've defined and configured in FlexMatch. Once that's actually found matches for the player team or group or just individually, it will take that and put it to a queue, and then the queue will decide based on the rules you've set whether what the best particular fleet to run on it. So let's say it's actually latency based. It's going to look at the group of players that we've got in the queue and find across all of them on average what's the lowest latency fleet to run this session on. In this case, it found Virginia. So it's going to choose Virginia. It's going to ask GameLift to provision a session for these players on a server in the Virginia fleet. Once that happens, GameLift will then respond back to the clients with respond back to the game service with the IP address and ports of the server that's been selected. And we obviously go back to the client with that. And then what the client will do is directly connect from itself straight into that GameLift server using the IP address and port. So GameLift completely gets out of the way when it comes to the actual game client-server interaction for the game session. Of course, introducing no additional latency there. So that's kind of really very fast overview of what the end-to-end flow looks like. So Bruce, is there anything kind of sort of thing that's kind of interesting about that end-to-end flow?
Yeah, the thing that I really like is when you look at the amount of overhead that the Amazon GameLift infrastructure is adding to the matchmaking process. You get to configure your rules. You can make them as simple or as complex as you want. So that's obviously going to add some time there in the matchmaking process. But if you remove that component, you're actually, from the time players make requests to showing up on the game server ready to play, you're seeing on the order of 2 seconds of additional cost there. So once GameLift's out of the equation and you're connected up, it's pretty fast end to end.
Yeah, absolutely. And when you've got a geographical distribution as well that we just see with all the different fleets there, you can really kind of put the game sessions as close to the players as possible, of course, giving you that best chance of low latency.
Yeah. So do you want to tell us a little bit about those rule sets themselves and kind of how you can, split up, your platforms based on the rule sets?
Sure. Yeah. Absolutely. Yeah. So this first kind of approach that we're going to look at, as Bruce just mentioned, is a way that we can structure our architecture to really build once. So this is, they're going to be the kind of remaining theme throughout the talk here. And when it comes to the end-to-end architecture, we're going to look at a way we can support multiple different platforms. In this case, we're actually not going to support cross-platform play. We're going to show you a way that you can do it with a little bit more complexity than we'll get to in a minute. And what we're going to do is we're going to keep our platforms separate from each other, but we're still going to have one end-to-end infrastructure across an architecture across everything. So what you see will be just one thing. There's going to be no kind of copies of anything anywhere. It's just all one thing. So we're going to start with PC. So this is essentially just what we saw before. We've got our PC calling our game service. It talks to FlexMatch, and that FlexMatch will run our PC matchmaking rule set and use the rules it has there to then determine what the match is, and then, of course, pass on to the queue and select a fleet from there. So let's add a new platform. Let's add a console. So now we're going to support PC and console for our game. But we don't want them to play each other, and really we don't want to have them in any way really kind of cross-functional. So we're going to add a completely separate console matchmaking rule set into FlexMatch. We're going to keep our game service as it is, and we're going to keep FlexMatch. All of this infrastructure, as I say, is all the same. But we're just going to kind of only match console to console and PC to PC, and only provision games that are going to run on one individual platform. But we can keep doing this. We can then add, say, hybrid devices to that next one, and a new matchmaking rule set for that, and then, of course, with mobile as well. So you can see we can just continually roll out new matchmaking rule sets when we want to add platforms. And this doesn't get us to cross-platform yet, but you can still see that there's just, even with that added kind of barrier, we still have just the one infrastructure and architecture end-to-end.
Yeah, I love that. You've got I was just going to say, you've got that single architecture, and with that single architecture, you can just continue to add different platforms. The challenge, of course, there is that you really are getting into a position now where you're segregating your player bases across those platforms. And so I think, why don't we, before we dive into the cross-platform play solution here, Pete, do you want me to take people through what a rule set itself looks like?
Please do.
All right, so this is kind of where the magic happens here, folks. And with these rule sets, you can see that it's a simple JSON scripting language here. We start out with a bit of metadata at the top, some bookkeeping where we have the name of the rule set and, in this case, the language version. And then we dive right in. So player attributes. Player attributes represent the data that you're going to pass in about your players that's used in the matchmaking process. And so in this case, what we're doing is we're setting up a skill-based matchmaker, and the skill will be determined by you in your backend solution. You'll pass that in, you'll tag it as a skill value, and then you'll see here in a moment the rules can then interpret that skill value and use it to match players. Next up, we have teams. In this case, we've defined two teams, a red team and a blue team. You can have a number of teams, and you can have a number of players on each team. In this case, we've decided that it's 3 to 5 players per team, giving you some flexibility as to the number of players that you actually need in order to get a match started. And finally, we get to dive right into the rule sets here. So this first rule that we'll define is the fair team skill. And what this rule is attempting to do is it's going to take the average of the players on each team within a given match that's being evaluated. And it will then compare that per team average to the average of all players in the match to make sure that all players in this case are within 10 skill points of one another. And it does that here by 2 fields, the measurements field and the reference value field. The measurements, you can see here we're doing a little bit of math. This is where we actually use that skill player attribute that we passed in earlier. And so we're taking the skill attributes of all the players and taking the average on each team in the measurement section. And then in the reference value, we're taking that value again, and this time we're flattening it across both teams. So we're taking the total average. And so you can see here we provide a pretty good mathematical representation of what you can actually do here with those player attributes that you pass in. In the next rule, just to give some kind of additional rule types so you can kind of see what these look like, we have a fast connection rule. This rule says that we want to prefer matches with fast player connections first. It's a latency type rule, and in this case, the max latency is set to 50. That's 50 milliseconds. So if the average of the latencies for the players in this particular match that's being considered is 50 or less, that match will be created. Finally, I want to dive into my favorite part of the rule set. This is where you can kind of turn over some of the tuning here of the matchmaking process to Flex Match and let it determine what the best thing to do is for you. And this section is called the expansion section. And so what you're going to see here is we're going to take a look at that max latency rule that we just defined above, and we're going to look at the wait time in seconds of players in the match. And if players are waiting for more than 10 seconds before they get in a match, we'll actually take a look at this rule and we'll relax that latency value from 50 milliseconds to 100 milliseconds. If players are still stuck in the queue and they haven't found a match within 20 seconds, we'll relax that value again. You can relax values of rules up to 10 times. And you can have an expansion here per rule that you've defined. So it really gives you a lot of the flexibility to balance between wait time and competitiveness of matches and latency all at once within a single rule set. And so you can see it's 40 lines of code, and you've got a lot of flexibility. So Pete, now that we've talked about rule sets a little bit, do you want to dive into then how we can simplify that overall architecture with adding cross-platform play?
Yeah, sure. And actually, really, we have it right in front of us here. So as you remember, we kind of added new platforms in our previous approach, and we saw how we might keep them segregated by having separate rule sets. And now Bruce has talked us through an example of a rule set. Shows how you can actually build different rules for different scenarios. But now if we want to do cross-platform play and we want to have one set of infrastructure, well, we can continue to do that from our previous example. But actually we can also now have just one rule set as well in a very, very simple way. This one common matchmaking rule set could be completely dynamic. It can continue to receive requests from our game service for all of the different platforms. Based on scenario, we can then say, hey, we want to allow PCs and consoles to play together, or hybrid and mobile, and then of course all the rest of the process remains exactly the same. So I mean, basically, I think the best thing now, Bruce, is to talk the guys through what that more dynamic rule set would kind of look like.
Yeah, for sure. So if we look now at what the cross-platform version of the rule set is, we're going to take the same rule set that we just walked through. You'll notice that now what we're doing here is in the player attributes section, we're going to add two new attributes. One is a list of platforms, and the second is a list of my platform. And what the list of platform indicates is the platforms that the player has available to the player based on maybe what they've purchased with regards to the different devices that they want to play the game on. And then in the second field here, you have the list of the specific platforms that they've opted into cross-platform play to play against. So while the player might be able to play on all platforms, maybe they're a hardcore PC player and they just want to play against other PC players and they don't want to have mobile folks in the mix. Conversely, maybe they don't care and they would like to be able to play against any number of players. So whatever you would pass in as the list of platforms there in that second field would give you then what we're going to use to make an intersection here in a moment. So now we drop down here to the platform match rule. So this is the only other addition to the rule set that I walked you through here a few minutes ago. And in this case, what we're doing is we're going to find the common set of acceptable platforms and make sure that each player in the match is playing on at least one of those platforms. And so this is a collection rule. It's a intersection type of operation. And then you see that measurements field and the reference value field again. In this case, what we're doing is we're finding the intersection between those two lists. And as long as there is, in this case, a min count of one intersection between those lists, then all of the players have essentially opted in to play cross-platform play with one another. If for some reason there was there was not an intersection, then that match wouldn't be created and it would be put back in the matchmaking pool. But what this gives you then, though, is the ability to quickly, with just the configuration of a few lines of code in your rule set, to enable cross-platform play among all of your players. So, Pete, what do you think about that?
Yeah, what I really like about this is, again, going back to that kind of one rule set approach where you can have things essentially dynamically controlled from outside of the rule set. So, in your case here where you're saying, hey, the player can define what platforms they would like to play against. I really love it. I think it's a really good way to kind of approach that. But equally, you could actually, using these same techniques, you could actually, be more restrictive as a developer and just say, no, I'm going to define in my rule set what platforms can play against each other. And even that doesn't kind of, stop you from changing or modifying it in the future, kind of at will and seeing what works. So, with those kinds of approaches and the abilities you've got here, I think it's, very, very powerful and, really, really great for various different use cases.
Yeah. Single architecture, and now you've compressed it into one rule set. And with that single rule set, now you've enabled cross-platform play. So, folks, we told you at the beginning there'd be a little bit of magic happening here, and here it is. You get that cross-platform play enabled. You get a simplification of your back-end architecture. And then, Pete, when we were talking about the architecture in the beginning there was that orange box, game services. And you talked about how you're going to let people know, kind of, peel back the cover on that box a bit and tell people how they can, perhaps if they haven't built their own game services backend, get that up and running pretty quickly with Amazon Web Services. Do you want to go ahead and take us through that example architecture?
Yeah, I'd love to. So yeah, as you rightly say, Bruce, this is definitely a kind of, if you haven't already got something, this is something, you could look at as an option to implement. Before I run through the services, I'm going to bring a few of them up, and I won't go into the details of each one. But if anyone's interested in learning a little bit more about this, feel free to get in contact. We'd be very, very happy to talk you through it. And additionally,
Pete, didn't you do I think you did a blog post, right, where you kind of dove into the details here in some pretty good depth, right?
That's correct. Yeah, I did do a blog post on a similar topic around serverless matchmaking, which includes some code examples, and I'll kind of point out where some of those things would be useful actually as I talk through. And the other thing is, I was just going to say that a lot of these services, in fact all of them, you can implement without the need to kind of manage or maintain any individual servers. They all kind of operate without you actually having to know or control what the underlying infrastructure is. So that, I know that's quite a nice benefit too. So we start with obviously our player and game client, as we have been throughout our talk. And in this case, what we're going to do is because we want to implement this game service that can be the front door to our matchmaking requests, we're going to look at a couple of AWS services that can help us with this. Firstly, we're going to look at API Gateway. So API Gateway, very, very basically, can offer a REST-based endpoint that's open. It's very highly scalable, and again, doesn't need any servers to be managed or anything like that. And essentially, we're going to open this up and say, look, when clients connect into our REST endpoint, they can, first of all, we might authenticate them, and we could do that using Amazon Cognito, and that's an optional piece, but if you wanted to, you certainly could. And Cognito can actually also be used for a player store as well. So if you had multiple platforms calling into this, you could, use Cognito as a way of obviously, keeping an eye on what platforms they're coming in from, and having maybe your own player identity sort of set up and unique identifiers that go across platforms, so you kind of know if they're coming from, say, Xbox or Switch, that kind of thing, and then also kind of keep your own IDs against them. So that's a nice additional benefit there. But once you've authenticated them and accepted that request, we're going to need to do something with it. So we'll look at AWS Lambda. Now, for those who don't know, Amazon API Gateway and Lambda are actually essentially configurable to talk to each other. There's no sort of boilerplate code that really needs to be done there or any kind of heavy lifting. It's it's a matter of kind of configuring API Gateway in a few reasonable steps to kind of call the AWS Lambda function for us and pass on that request. So we're going to do that. And actually, this is where we get into our first kind of bit of code that we can kind of share with you on the blog post. I actually did share some code written in Python as to kind of how to call game lift from AWS Lambda. So feel free to go and take a look at that. It'll be on our game dev blog. So that's something of interest. And that's exactly what we're going to do here. We're just going to call flex match in this case to ask for a match, and essentially that's going to go and run that rule set that we've been talking around and that Bruce has introduced to us. Once it's actually managed to find a match, it's going to go and again talk to the queue and find a fleet and essentially provision a game session onto a server for us. And that's great, because what's happened there then is that, and we've actually succeeded. We've done the job, and really what we've done in this case is we've found a match. We've got a server IP address and port. In this very simple scenario, we're just going to assume that the client is actually quite happy to poll back into API Gateway and check the status. So you see here the secondary flow here is it's going to check in, and then what we'll do is we'll have a sort of secondary task for the Lambda function to actually just check the status of the match with FlexMatch. So you can actually do two things. You can request the match, and then subsequently you can just check the status of the match, and FlexMatch will keep an eye on that for us and tell us the server IP address and port and the match that's been made once it's succeeded. And that's in this case how the game client will get the server IP address and port details to play the game with. Once it's done that, it will actually connect directly to the server as we've been talking about. And that's your kind of very simple flow. There's a few different ways you could cut this, and this is just a kind of, like I say, a quick, simple version just to show you kind of how it could work. In addition, though, you could add a couple of different elements to this to get an additional benefit. And this would be around kind of managing DDoS attacks, which is quite a common thing in the gaming industry. They're usually quite high target attacks for DDoS. And by implementing Amazon Route 53 in front of your API gateway, you actually get free access to AWS Shield Standard, which helps to manage and mitigate DDoS attacks and kind of help deal with them as they actually happen on your system. And essentially, you can do things like setting up WAF rules, things like that, to kind of manage and mitigate and really reduce the impact of DDoS on your game infrastructure. And actually, when you look at that in combination with GameLift itself, which is a highly scalable auto-scaling system for your game, you can kind of preempt and manage essentially the DDoS attack, or certainly manage it as it's happening. And also, you've got GameLift, which can help you absorb some additional attacks and connections that might be attempting to hit your servers. So with the combination of the two, you put yourself in quite a good position from a DDoS perspective. So yeah, that's really kind of a quick introduction to kind of an example architecture. Is there any kind of call-outs that you've got on that, Bruce? You kind of find interesting there?
Yeah, so, I as a manager, I don't get to write code very much anymore. And so what I love about this architecture is that there actually isn't a lot of code here to write, is there? Like, you're essentially configuring some Amazon services here in the back end. You're writing a little bit of glue code. Like you mentioned in the Lambda, you've got some code there that you've got samples for. But this actually is fairly straightforward to set up, get configured, and get running. And there's additional flexibility that you can have. If you don't want a polling-based solution with FlexMatch, for example, you can plug into SNS notifications and be able to be notified when matches are created. So this is, I think, a really good starting point, and it kind of branches you off in a lot of different directions that you can then go in.
Absolutely. Yeah, for sure. So Bruce, take us home. Tell us all about the...
Yeah, so today we've talked about a lot in the past 45 minutes. We've told you, why you'd want to add cross-platform play to your game. You can build a stronger and larger community for your game. We've taught you a little bit about how you can simplify your architecture with Amazon GameLift and its matchmaking solution, FlexMatch. And in addition, we've talked to you how you can speed up development time by powering your multiplayer game with AWS and with Amazon GameLift. So I think with that, Chris, we'll turn it back over to you here real quick for questions.
Yeah, great. Thanks, guys. So now before we begin with today's Q&A, I'll ask you to please fill out the feedback form that is open on your console. And to complete the form, please press the Submit Answer button at the bottom of the page. So thank you in advance for filling that out. Your participation in the survey allows us to better serve you. And now onto the question and answer portion of our event. As a reminder, to participate in the Q&A, just type your question into the text box located below the media player. Then click the Submit Question button. And it looks like we already have quite a few good questions here. So we will just start with, just get started right here. Here's one. Does the server just support matchmaking and lobby, or can it support sessions during the match, like starting some scripts on the server side?
Yeah, Pete, you want to take this one?
Yeah, sure, absolutely. So essentially, there's two kind of components that we've introduced today. One of them is FlexMatch, which really does handle that matchmaking logic for you and is a great framework for running your matchmaking rules for you with our algorithm, essentially, to make sure it's fast and efficient. And that really does handle that. It focuses on that, and it does that very well. But on the other side of it, we have GameLift itself, which will run your dedicated game sessions for you once we've found the match and we've found a location to run the game on. So this would be code that you write that is actually your dedicated game server itself. So that might be written, in Unreal or Unity, those kinds of engines, and you can essentially execute any script or logic or server-side logic that you like on there, and kind of do anything you need to do from your game server's perspective. So essentially, the starting of a script on the server side is something that GameLift really kind of helps you with. Actually, you can also execute scripts independently of engine as well. So as in, you can have the game server, dedicated game server running on that machine that we've got for you. But you can also execute some side scripts as well that need to do certain things around the machine itself. Maybe do some logging or kind of, start up other supporting applications on your machine. So that's definitely, there's kind of two sides to it, and the GameLift side definitely handles that for you.
For sure.
Okay,
all
great.
Right. Question.
Yeah, next question. We got several, so I'll try to get through these. Here's a good one. How cost effective is this for small indie studios?
Yeah, so I can jump in on this one. So we find that GameLift in general is cost effective across the studio set. So for the small indie studios in particular, this really helps if you don't have dedicated engineers to build a back-end services infrastructure for your multiplayer game. Essentially what you're doing is you're hiring GameLift to do that for you, and we are able to do that at a fairly low cost once you add in things like spot instances and Fleet IQ, that service that I was talking about earlier, where you can get up to 90% off of what normal EC2 prices could be. So we find that this is extremely cost effective for small studios. For larger studios, they see a benefit as well, especially on the cost savings front. They may have already invested in a lot of services back-end infrastructure, but when they're trying to get their game to scale, for example, or if they started out a game that was peer-to-peer and they find that they really need dedicated servers in order to get that gameplay experience, it's a pretty quick way for a more mature, larger studio to quickly get up and running on dedicated servers. So we think it's cost-effective across the spectrum.
Great. Another one. You mentioned 50 millisecond latency. Is that end-to-end? In other words, a device in Virginia will see a device in Singapore with a 50 millisecond delay?
So the 50 millisecond latency, if you're using all regions, is the average latency that all players are going to see within the match. So you might have an outlier that is more than 50 milliseconds. That is that round-trip time from those devices to the server, but it's the average for all of the players in the match. And so what we're saying here is you can see that average latency of 50 milliseconds. Peter, anything else that you'd want to add there?
Yeah, one thing I'd like to sort of throw in here is that, maybe we could have sort of explained this a slightly different way on the talk, is that you can actually matchmake based on latency, and that 50 milliseconds in a FlexMatch rule set is trying to pull all the players together and match them based on their latency. So the first thing it's trying to do is it's trying to say, I'm looking for other players that are going to have a sub 50 millisecond latency to the best region, in AWS. And then subsequent to that, once that match has been found in FlexMatch, we pass it onto that queue. And if you remember, I mentioned that the queue itself will try and find the lowest latency fleet for that particular group of players. So when you use those two things in combination, your rule set's actually finding an even latency for all of your players. And then after that, the queue is actually finding the lowest latency experience for all the players. So that kind of, you can avoid that kind of, will I have a really low latency across the world by, matching your players together in a low latency way, and then of course using the queues. This only really becomes a concern if you actually have two friends that want to play together, across the world. And of course, usually they know that at that point. They're much more happy to accept a slightly higher latency in that type of scenario.
Yep.
All right. Here's the next one. It's great that your platform is elastic, but when we have more users connect, is cost based on time spent on the server, bandwidth used, CPU overhead, or number of player connections?
Pete, you want to grab this one?
Yeah, I was jumping right on it. So this one is you kind of got basically two of the points you picked up. You're absolutely right. So how GameLift is actually priced, it's essentially based on the amount of server time that's used for across individual machines. So essentially, if you have the ability on a virtual machine in AWS to run, let's say, 10 game sessions on one server, and each of those particular game sessions can support, let's say, 10 players each. You can actually auto-scale GameLift based on player sessions or game sessions. But let's say one server, you can run 10 game sessions with 10 players, so it's 100 players. For the amount of time that you're actually using that server, it's essentially a per-hour billing model, just like you would find in AWS EC2, and you just pay for that particular usage as it per hour as it kind of goes through. We have actually just recently introduced something we call, essentially spot pricing, but we use an algorithm to make it a very, very safe way of running spot pricing on GameLift. Essentially, we predict if your session is going to live on a spot instance for its life. So let's say it's a 10-minute session. We kind of forward predict it, and if we think it will, we'll run your game session on spot. And depending on whether you're running Windows or Linux, you can have either a 40% roughly for Windows cost saving on your instance costs, or up to 70 around about as an average on Linux. So it's quite significant. There is one other factor to the pricing, and that is, of course, bandwidth out. So the amount of bandwidth that your game pushes out to the players is also another kind of factor in the billing. If anyone's interested in this and looking in more depth, we can certainly follow up with you, and we can actually do like a total cost of ownership analysis with you to give you a really good idea of how much it would cost to run your game. So yeah, I don't know if you had any other sort of things to throw in there, Bruce, but that was kind of my thoughts on that.
Yeah, I think you covered it. Just for spot instances and a quick definition there. So EC2 has at any moment in time extra capacity, and so what they have is they have a bidding model that you can use to bid on those that extra capacity at a discount. And as Pete was mentioning, depending on Windows versus Linux and some other considerations, you can get a significant cost savings there. And what we ensure is that if EC2 asks for that capacity back, which they occasionally do, we won't be placing your game servers on instances that could be taken back. We have a pretty low risk tolerance there, and so we make sure that you're getting those instances at a highly reduced rate, and yet without the risk of interruption.
Excellent. Next question. Does GameLift Flex Match have any built-in support for party-based matchmaking, such as if I have a couple of friends that I want to play with on the same team, so we want to get matched together against other players?
Let me answer this one, Pete. So yeah, party-based matchmaking. If you have a way in which you can group players together, you can send multiple players in on the same matchmaking request. And so if you want those players to be together on the same team, all you have to do is add them to the same request, and they'll be matched on the same team.
Great. And next question, how do we maintain a user's identity across disparate platforms? As an example, Steam identity and Xbox. And has Amazon thought of a master identity such that my identity, avatar, and rewards in-game can move from and across platforms so that my friends can find me?
So we actually have something that can really help with exactly this kind of use case. And it's actually not GameLift or FlexMatch directly, but it's something we have in our set of game tech services called Amazon GameSparks. And GameSparks is essentially a kind of backend as a service platform that helps you to build out and very easily implement various different features of your game. One of them is player and identity management. It really does help with that. It also integrates with the game services as well, such as Xbox and PSN, that kind of thing, to kind of help you with just this kind of use case. So, definitely take a look at Amazon GameSparks as a way of doing that and seeing kind of how you can manage that. And again, do get in touch with us if you have that interest in that. We can talk more about it with you.
Great. Next question. How do you guys feel about disparity between control schemes and screen sizes tilting the player field too far?
Yeah, so this is actually, I think it gets to the core of what interested me in this topic in the first place. I think there are a number of assumptions that developers have been making for many years about what players will tolerate with regards to multiplayer games. And I think there are a number of games that have been released recently, especially that are challenging some of those conventions, right? Like they're available across all devices. And what we're finding is they're willing to experiment, and they're willing to say, hey, players, if you really value playing with your friends and you want to do that more often, and you can only get the game on mobile, for example, you can do that. You can play with them. And if they're willing to play with you as well on an experience where you might be at a slight competitive disadvantage, hey, you know what? Like, it's up to you, the player, to decide what is right for you. And that's what we're trying to do with FlexMatch and these rule sets is, as the developer, you get to make these trade-offs. You get to decide, hey, how cross-platform do I really want to be? What size do I want to make my matchmaking pool, and things along those lines. So we think that this is kind of an exciting trend in the industry where there are a lot of conventions that are being challenged here. And I'm excited about the future direction, and I think services like Amazon GameLift with FlexMatch are kind of poised to help developers in this new unknown.
Okay, we probably have time to squeeze one more question in, and if we didn't get to your question, our presenters will be able to answer them over email because we all have them archived here for you, so don't worry too much about that. So last one for the live presentation, though. How would you approach making a game server for GameLift for a Unity game? Would a headless instance of the game itself be appropriate for GameLift as a server, or is it better to do a custom server solution?
So certainly, yes, you can. Actually, either will work, and it does depend on your use case. So I do often use a headless server in Unity for my own testing and running with, using the server-side SDK. On that, we actually have support in our server-side SDK for both C++, which would support Unreal, and also a C# version of the SDK, which of course supports Unity. So you do have the flexibility on options to either essentially import the SDK into your game server, which can essentially run as an instance of the server for you in a headless way, and then as long as the SDK is integrated properly, that will work absolutely fine for you. Or if you feel it's better for your particular use case, and you do have very specific custom things you want that server to do, like you've got some physics computations, things like that, or anything, server specific, build your own one, and again, that will work just as well. It already just comes down to the implementation of the server SDK with your server. So as long as that's fine, both will work absolutely perfectly for you.
Okay, and that's all the time that we have for today. For more information related to today's webinar, please visit the resource link open in front of you. Within the next 24 to 48 hours, you'll receive a follow-up email with details and a link to today's presentation on demand. And with that, thank you for attending today's webinar, Building Cross-Platform Play for Your Multiplayer Game, brought to you by Gamasutra and Amazon. This webinar is copyright 2018 by UBM. The presentation materials are owned by or copyrighted, if that is the case, by Gamasutra and Amazon, who are solely responsible for its content, and the individual speakers are solely responsible for their content and their opinions. On behalf of our guests, Bruce Brown and Pete Chapman of Amazon, thanks for your time and have a great day.